Alright, we're looking at GCRT number 1, objective 1, and this video deals with worksheet number 3. Worksheet number 3 basically deals with at the heart of what goes on with the center of dilation. And it asks us to understand when the center is on or off of lines, what it does to those lines. So here is our pre-image setup. O is our center of dilation. We have A, we have B, and we're being asked to dilate it by a value of 2. Now, I'm just going to rough it in, but basically you know what a dilation does is it either expands or contracts or reduces our points on the ray from O through that. And so if you're going to double it, 1, 2, A prime would be somewhere up here, and then B prime would be on its ray, double the value, say somewhere about here. One thing that I want you to notice is that yes, the points moved, but they moved along those rays, not making a new line at all. So no new line was formed. But points move either closer or further away depending on the scale factor. I just want to show that that wouldn't matter either if we decided to use a scale factor of like 1/2. So here again is our original points. If we were to scale this by dilate it by 1/2, A prime might come here, B prime might come here, but again no new lines are formed when you dilate and your center is on that line. Now that changes though when our center is off of the line, as it says here, when it's off the line. So when O now, the center of dilation, is off of the line, we will see a much different experience happening with this line. Before, no new line was formed. But as we look here, it says to dilate 3 times bigger. So I'm going to make a good long ray, because 3 times bigger is quite a bit. So there's a long, nice ray, and 3 times bigger going this way. Now again, I'm not doing an official dilation, but I'm going to dilate it 3 times. Once, twice, 3 times. And again, I'm kind of estimating, as you can see, once, twice, 3 times. Now, look what happens. A new line is formed, certainly is formed. You see that this line is pushed further away because we are multiplying it by 3. So again, it expands it further away. Had I done this with a little more precision, they of course would be obviously parallel, but dilations always produce parallel lines in their dilations, and so we see that. So what happens then if our scale factor was, say, 1/2 instead? So again, we would create the rays because all points in a dilation move along their dilation ray. And in this case, instead of expanding further away, these points will be pulled closer to O. So A prime will be somewhere in here. B prime will be somewhere in here, B prime. And again, we will get a line. Whoops. That wasn't quite as good as the last one, not estimate-wise. But again, you get the idea that we're getting pulled closer. So if it's a contraction, it'll come up closer. If it's an expansion, it'll go further away. But I guess the point is new line formed. So a new line is formed whenever you dilate something. So let me just give you a quick example of kind of what I mean by this and what takes place. So let's say we had these 2 intersecting lines, and let's put O here, make this A, make this B, and let's make this C. Now let's do a dilation about O at, let's say, 1/2, okay? So everything gets pulled 1/2 closer. Now O is on this line, so A comes closer. Here's our A, and again I'm just estimating. C will come a little bit closer. Here's C prime. Notice no new line is formed here because O is on this line. But B will come closer. So again, we would form a ray through B and come half the distance. And guess what? In doing so, it pulls B closer and it forms a new line, doesn't it? Because this line, O was not on it, so we create a new line. This line here was O was on it, so no new line is formed. You can see again how parallel lines are formed in dilations.